Hi everyone. Good evening. Good evening all. All we are here for the day 3 bootcamp Codeavour 7.0. Hi. Just type your name and hi in your chat box. Okay, so today we are here for the day 3 event and it's gonna be the track 2. So we'll be going to discuss track 2. Good evening everyone. Good evening once again. Let me just switch into the presentation, then we'll start. Okay, so I hope my screen and everything is visible for you. We are here for the Codeavour 7.0 Innovation Fest for the next generation. So it's not just a competition, we are also providing a innovation fest for our next generation kit to empower through the technology. Today we were supposed to discuss the track 2. We'll go deep into the track 2. What are the things you can do? What are the tasks you will be going to discuss in the track 2, and what are the rules and regulations you need to follow? What will be the rules and regulations in the game, and how you can code it? We'll have going to have a deep look into all these things. So don't worry if you are having any queries or any doubts in between the section, especially regarding the discussion of challenges. You can directly put it in the chat window. Once we cover the challenges part, we'll going to have a discussion on it. Okay, so every time note down your queries. So let's start the section. So, as I mentioned earlier, the track 2 is the Wellness Wave AI Robot Challenge, where the kids can create robot, or the kids can build the robot that will be able to tackle the challenges and solve the issues related with the health and wellness. Okay. So here the kids will be able to interact with the problem solving with robotics, and also there will be a teamwork that will be able to empower them. So let's have a look what are the challenges they are going to see it in the track 2. So over here in the PPT image, you can see that various points are marked. For example, home point 1, home point 2, marathon track, fish releasing point, water sample, coconut beach, forest track, camera point, blood bank, blood donation van, yoga park, hospital and pharmacy, water testing lab. So all these points are marked where we are going to do various tasks. So there are already predefined or presetted 8 challenges the kids needs to solve here. The robot needs to be created or built to solve all these challenges. So let's have a deep look into it. You can see it over here in the arena. The home point 1 and home point 2 marked over here. You can choose either home point 1 or home point 2 to start your project. And we are also provided this camera point to do some AI projects. Then also here we are marked the challenges. So you can see that starting from 1 to 8 challenges are provided. First challenge is yoga challenge, then there is mosquito prevention, then there is water hydration. So we'll have a deep look into each and everything, and let's see how the kid needs to create their robot and how they can be solved during the track. So starting with the first challenge, the yoga. So in this posture, there will be a challenge placed on the number 1, where the robot needs to be used to change the yoga position. For example, now this yoga is, or the posture is in warrior pose. So we need to convert the warrior pose into a triangle pose by using the robot. So that is the first challenge a kid needs to solve here. So this yoga challenge will be going to restore the balance and encourage a healthy lifestyle, and the kids needs to use the robot for it. For example, in the first position will be something like this. The kid needs to change this warrior pose into a triangle pose, just like this image. So in this track 2, you need to keep very important thing. There will be two type of control here. You can either control your robot manually, or else you can control it in autonomous. But the important thing you need to note down here is the points will be different in each cases. If you are controlling your robot manually, the points will be half. If your robot is working autonomously without any human interference, then you will be able to get the full score. So the points are mentioned on the top right corner here. So you can also check it. In every challenge, the points will be mentioned. So in the manual case also, in case of the autonomous, the points will be vary. So while you are training your robot, you need to keep this in mind. If you are able to do the easy ones, try to do it in the autonomous mode. So you'll be able to get the full points. So we already discussed about the yoga. Yoga was to adjust the position, adjust the posture. You need to change the warrior pose into a triangle pose. Then the next challenge, challenge number 2, mosquito prevention. So in the track 2, there will be an area provided with number 2 and there will be this fish and this model will be placed. What you need to do is you need to control this shift. You can see that there is a one B3 extended into this arena. So what you need to do is you need to tackle this particular part with your robot and release these two fishes into the pond. So we are using this particular task is to solve or control the mosquito population. So this particular fish we are using is mosquito fish. So that will be able to eat all these mosquitoes eggs and it will be able to control the mosquito population. So the initial position was like this and you need to place your robot on this path and control this or tackle this particular extension provided over here and release the fishes into the pond. But one important thing you need to keep it in your mind is you need to release both the fishes. If you are only releasing one fish partially, you only get the half score. Okay. In the case of manual also, in the case of autonomous, you only get the half score. You can see it over here in the picture. You only able to if you are only able to release one fish, your points will be reduced to half in case of manual as well as the autonomous. If you wanted to note down the points, you can also note it down. So this was the partial condition and this was the full condition. So in this picture, you can see that both the fishes are released. So you got 20 points in manual and 40 points in autonomous. Does anyone having any doubts on this? If you're having any doubts, just post it in the chat window. I'll have a look at it. Any doubts? Okay, good to go then. If you're having any other further doubts, just note it down. We'll discuss at the end of the section as well as once the challenges is covered. Okay. So next thing we need to discuss is the challenge number 3 and it is organizing the marathon. So here you can see that two different parts placed. So what we need to do is or what the robot needs to complete in this particular challenge is it needs to ensure the safety and smooth execution of a marathon. So we need to place some barricades or we need to place some traffic cones in some drop points. So the position will be marked. So we need to avoid the vehicle entry as well. So the position will be already marked in the arena. So we need to take this two traffic cones from the home point 1. Either you can carry it in the beginning or else you can come back to the home position and carry it once again. But make sure that you can only add these traffic cones in home points only. So you can carry it the home point, sorry, traffic cones. Once it's done, you need to take it from that point and place it on the number 3 marked on the arena and it will be on the road. You can see that one square is also marked around it. See it over here in this picture. Make sure that you are aligning two cones together If you are only placing single con, or if your con is slightly outwards, or if your con is fall down and it's in tilted mode or something, it will be going to reduce your points to half. So always note down, you are placing the cons, you are also placing the cube boxes and everything properly inside the square box. If it's somewhere outside of the box, your point going to be reduced into half. See it over here in this pictures. So in all these cases, the point is half. And if you are perfectly aligning it within the square itself, you will get the full score. And if you are perfectly aligning both the cons inside the square box, you will be able to get the bonus points as well. So try to do it very carefully, take your time and do it. So that was our challenge 3. The next one is challenge 4, staying hydrated. So what we are trying to implement here is we are trying to teach the students the importance of be hydrated. For example, for this marathon, we'll be providing the coconut water from the forest and we'll be going to place it near to the area. So for that, there will be a coconut tree on the arena. The coconut will be hanged on it, just like you can see it in the presentation. Your robot needs to pick it from here and drop it over here in this area. And in this case also make sure that you are placing it properly within the box itself. You need to collect the coconut from the tea and deliver it into the refreshment stalls near the finishing line. So you can see it over here. This is where you are going to place your coconut, and also make sure that it is placed within the square boxes itself. So that was our challenge 4. Then coming to the challenge 5, it is snake bite rescue. So over here what we need to do is we need to get the medicines from the pharmacy and give it to the residential area. So for example, this is the pharmacy. You can see that two set of box placed over here. The first one is this red one is the snake bite rescue medicine. So what you need to do is you need to take the antivenom from there and you need to give it to the delivery to the forest area. So for example, your robot needs to come down here in the pharmacy and collect or pick and place the particular antivenom or the medicine and take it into here in this forest area. So this is where you are supposed to be collecting the antivenom. This is the area where the pharmacy is and collecting it, going on this way back to the forest. So I hope it's clear, and always needs to make sure that you're aligning or you're positioning your cube boxes or the boxes you are using perfectly inside the square boxes you provided. So the next challenge is also you need to take it from the pharmacy. It is the vaccination. So over here you can see that there were two set of medicines provided in that pharmacy. The first one was the snake bite antivenom. Then the second one is the vaccination. So you're gonna need to take the vaccination from here and drop it in the residential area. So you can see that this is where the vaccination or the pharmacy was there, and you need to your robot needs to come all this way and come here and drop it on this particular box provided in the residential area. So again, you need to keep it in your mind. It should be within the box itself. If somewhere some part of the box is outside or something tilted or something, you're going to your points will be reduced to half. And ensure that the children receive the polio vaccine to protect the communities. So in each challenges, the kids are actually learning about few things related to the health and well-being challenge. We face it in our daily life. So the next one is the AI project. The AI challenge, we have it in the track 2, where the kids needs to work on, or they need to collect the blood bank. They need to collect that particular blood report and put it into the camera point and analyze which type of blood they need to use and give back to the hospital. To collect it from the blood bank and give it back to the hospital. So for that step, first there will be two different set for junior, senior and elementary. For elementary, they need to use the recognition cards to train the model, whereas for the junior and senior, they needs to use the machine learning to use develop the code or train the model. So for the elementary, it will be going to be recognition cards 1 and 2. And for the junior and senior, they need to train their robot by using the machine learning environment. So that is the criteria. You need to note it down in the challenge 7. And the procedure will be very simple. The referee will be going to toss a coin. So in that coin, for the junior and senior, it will be going to written as a positive and B positive, and for the elementary it will be 1 and 2. So they will be choosing which cube needs to be placed in the hospital. So that is the report you need to collect from the hospital. Once it's collected, you need to put it into the camera point to analyze it, and from there you will be able to get the report like which blood you need to use. So you need to go to the blood bank, and you can see it over here. You need to take the blood bank and put it return back to the hospital. So that is the challenge. So here you will be able to collect the blood and put it return to the hospital. So that is the process. You need to do it in the challenge 7, identifying the blood. So keep this in your mind. The elementary students are going to do it by the recognition card, or they are going to train it by the recognition card, whereas that senior and junior is going to use the ML environment to do the coding. I hope it's clear. Then the next challenge is challenge E, testing the water. So over here, what we need to do is we need to take all these water cubes and put it into the water testing lab. For example, we need to make sure that water is drinking water, and it is also not contaminated with any other illness or something. So the kids are going to go to the residential area, and they need to collect, sorry, not the kids, the robot needs to go to the residential area, and they need to collect all the water samples from here. You can see that these are the 4 samples they need to collect from the residential area, and they need to put it back to the water testing lab. So these are the challenges coming. You can see the picture over here. This is where the residential area was placed. You need to collect, or the robot needs to collect all these 4 and place it back to this water testing area. I hope the challenges are clear for you. The first one was changing the yoga posture. Then the mosquito prevention were there. Then the kids needs to work on the traffic cons. They need to provide the support. Then there were the snake anti-venom, transferring it from the pharmacy to the forest. Then there were the pharmacy where the kids are providing the vaccination from the pharmacy to the residential area. Then the AI challenge where the blood test is determined, blood type is determined. Then there is the challenge 8, testing the water, where the samples are collected and put it back to the water testing lab. So these are the 8 challenges we need to tackle by using the robot we built. I hope it's clear. If anyone is having any doubts on these challenges, just share the doubts in the chat window. Any doubts on it? Yes, you can start from home point 1 or home point 2. But if you are, for example, we need to add the traffic counts from the beginning, or you need to add it later in the game. So that addition, if you wanted to add anything to your robot, you can only do it in the home, from the home points only. So this traffic cons, you need to take it from outside. So either you can place on your robot in the beginning itself and tackle the challenges, or else you can come back to the home points and collect it from there. We don't have to take all the four buckets in one time. That is not mandatory. You can do it by your wish. If you have that kind of alignment in your robot, you can do it that way, or else you can collect it one by one. But the issues, you also need to make sure that you are doing it within the time limit. So we'll be discussing the time details and other rules and regulations later. So no worries on it. So for the certification, you need to fill out the Google form, sir. At the end of the section, you'll be able to get it. Okay, while you are creating your robot, you need to make sure that your robot will be able to complete all these tasks. Like what the challenges provided over here, your make sure that your robot are able to complete all these tasks provided. So these were the challenges in total. If you're having any doubts, we can have a talk. Yeah, you need to just pressure on it. Let me just show you the slide once again so you can have a look at it. The first challenge. So this was our first challenge. You can place your robot here, not on the side. You need to come on this way and place your robot on the side. So when you push onto this levers, the position will be going to change it. See? So no worries on it. So your alignment will be going to change it. The yoga posture will be going to change it. So you need to make sure that there are some kind of extensions on your robot that will be able to do this particular task. Any other doubts? No, sir. We are these tracks, all the objects you see it on the track will be coming along with the arena kit. So what you need to create is a robot. So we'll discuss about the mechanism part later on this PPT. So we'll be able to get a more clear picture on what are the parts you need to add while you are creating this particular robot. Okay, let's have a look at the challenge 4. So the challenge 4 was staying hydrated. So it is very simple, sir. We just need to collect the coconut water from the tree, and you need to go all this way to come back to here in this point and place it over there. So it's more like a pick and place activity. You need to pick it from here and drop it on this particular point provided in the track to arena. Any other doubts? If nothing is there, we'll go to the next section. Regarding the components, you need to create this entire project in the PictoBlock software, and also you only can use the Quirky board here. So, what are the other extension, or if you wanted to add any other sensors, you can all add all the sensors which will be able to compatible with the Quirky. If you're having this Quirky kit within the school itself, you can use that particular one. Otherwise, if you visit our official website, you will be able to get more details on it. Just go to that particular track 2 and you'll be able to see the details over there. So, okay, so let's continue. And also make sure that you are filling out the Google form provided in the chat window. Once you've done it, then only you will be able to register it, and also then only you will be able to get the certifications. So the next thing is, what are the rules as per the category? I already mentioned there were a few difference in the challenges 7 for elementary and junior senior section. So for in case of elementary, they can create or they can participate entirely in manual, or else they can use it in the autonomous robot. So there is no criteria, they only able to use the manual or autonomous. They can use all the challenges by using the manual robot or autonomous robot. But coming to the case of junior and senior, they need to complete at least one robot autonomously. So that is mandatory. They can't do all the activities manually. At least they need to do one single activity by using autonomous. So while you are training your model, keep this in your mind. In the case of junior and senior, they need to create the robot at least one challenge autonomously. Then coming to the second point, there will be 4 minutes to complete the entire challenge for elementary, and for the junior and senior, there will be only 3 minutes to complete the challenges. And in the case of elementary, for the AI challenge 7, they need to use the recognition cards, and for the juniors and the seniors, they need to train their models by using the machine learning environment to train the images of blood report cubes, they need to use the machine learning environment. Whereas for the elementary students, they can simply use the recognition cards like 1 and 2. And these are the home arenas. So it's like a cool down zone as well. As I mentioned earlier, if you wanted to add your traffic cones, you can only do it over here in this home points. Then mode switching card. So we already discussed we are having two different modes here. We can either control it by manual, or else we can control it autonomously by using the line following technology. So if you wanted to use both the things, for example, while you are creating the model, while you are training the model, you feel like some challenges are not able to do it autonomously. What you can do is you can start the project autonomously and finish few challenges. Once it's done, you can use your mode switch card and switch the autonomous to manual. But keep this in your mind, whatever you are going to do, you need to take the permission from the judge or the referee. So once you inform, you will be able to switch in between the autonomous and manual. If you are not using this mode switch card, or if you are directly changing the modes in between your games, it will be going to consider as the foul. So let's have a look how we can learn or how we can build the line following robots. So the first rule you need to keep it in your mind is, while you're creating your robot, the size of the robot must be coming inside 20, 20, 20 and centimeter. So the home points will be marked along this particular details. So size. So if your robot is larger than it, you will be directly going to be eliminated. So Whenever you're creating this robot, keep this in your mind. All the parts will be coming within this size limitation. And also, your robot's weight must be coming under the 1 kg. So if it's more than 1 kg, you won't be able to participate. Your robot won't be able to participate. And also keep this in your mind, your robot should be the battery operated. So it needs to work independently without any wired connection. Then the battery should be coming under the 5-volt category. And also while you are creating your robot, if you are adding any other extensions for the pick and place or any other particular use to complete the challenge, there shouldn't be any sharp edges or any hazardous materials used that could be able to damage the truck or anything. Then also while you are using or while you are creating the robot, you need to use the Quirky series components as well as you need to use the picto blocks to do the coding part. So these two things are very much mandatory, and you can, if you wanted to use any other sensors like IR external sensors like IR or something, you can use it. It must be compatible with the Quirky series. That is the only criteria. And these are the parts, the construction or extensions you can add it to your robot. For example, if you wanted to add any 3D printed part, you can add it, laser cut part, Lego components, or even you can add the ice cream sticks as well. There is no issues. And you can also use any sensors. That point I already mentioned. You can use any sensors that will be able to compatible with the Quirky series. And don't use any exposed sharp edges, and also no hazardous materials allowed. And if you wanted to keep any batteries as extra, it will be very much a good choice, because if your robot is working based on the line following technology, if your IR is taking too much time, or if somehow the battery is drained, the IR value will be fluctuating, so it won't be move easily, so it will be going to affect your challenge task. And all the pictures provided over here, you can use it in your robot. Then let's start a look at how you can do the coding. So over here I was talking about the autonomous robot. For the manual robot, you can do it in the block coding and control it with the up arrow, down arrow, left arrow keys. That was very easy. But how we'll be able to do it in by using the line following technology. So we were seeing this black and white lines path in the sheet or the track. So how the robot will be able to follow this particular path? So let's have a look at, if you wanted to scan this particular QR code, you can take a picture as well. This will be the link to guide you through the LMS part of line following. So for further details, you can refer this LMS part. So it will be something related to the Quirky advanced line following. If you wanted to take a snap, you can take it now. Okay, good to go. If you are having any doubt, put it in the chat window. I'll have a look at it. Okay, so in the case of coding, we can do the coding part in the block coding as well as Python coding. Today, I'll be going to showcase you how we can do it in the block coding environment. So you will be able to have a basic regarding this. So let's go back to the slides. So when we creating this advanced line following technology, it will be good to use the PID programming blocks. So PID is for the advanced purpose, and it will be going to take the feedback, adaptive feedback, PID's full form is proportional integral derivative. So what is the use of this particular thing? So it will be able to help your robot to make the tracking is more accurate. So it will be going to, if your robot is making a particular turn, if your robot is doing any activities based on the line following, it will be more accurate and it will give you a more high speed line following as well. So you can see it, the in the normal case, we only add in the normal line following technology, we only add this set parameters f to this particular value t1 and t2. So this is the parameters which are going to control the speed of your, these are the parameters which are going to control your speed. But in the case of PID, we are having these three set of blocks where Kp, Ki and Kds are the constant values. So if you wanted to change it, you can change it in your code and check what are the difference you are having in the robot. And if you are placing these values are the constant, while you are making the turn and while you are creating your turnout, it will be more accurate. Then in the case of speed parameters, so here we mainly having three set of values. We can have a base value. The base value will be the one who's going to control the normal speed. So if your robot is going forward independently, that will be this base value will be the speed. And if your robot is taking a turn, we can adjust the speed from the minimum value to maximum value. So it's up to your wish what are the values we need to add. Here in the case of, I adjusted it with minimum value of 0 and the maximum value 80. So while your robot is making a turn in case of line following technology with the PID, your robot will be able to go to 0 speed up to the 18 maximum. And also we added a turn set speed as well here with the 50. So this is the few steps. Then coming to here, let's see how we can initialize our robot. So here we provided two conditions. These codes are with the adaptive feedback, like with the PID, and these two codes are without the PID and the normal line following technology. So here in this case, you can have three set of configurations. Either you can use the internal IR sensors in the query key, like the IRL and IRR, or else you can connect two external IR sensor. You can place it here, just like you can see it on this particular presentation. You can align it over here. And in the third condition, you can use three external IR. Okay. So these are the category. We are having three different type of configuration. Either you can use the internal IR sensor or else you can use the two or three external IR sensors. So while if you are using this, you need to, if you are using the external one, you need to use the PID, and at that time you need to use this particular set of blocks. So initialize two with IR sensors, and if you are using the internal one, you can change this A1 to IRL and IRR. Change the left to IRL and IRR, or else if you are using the three set of IR externally, you can add it, change it into 3, and this will be the particular block you are using. So in a single block, you can adjust all three IR sensors. For example, the left one is set into D1 and middle one is set into D2 and right IR is set into D3. So all these IRs will be external. So while you are using the external or three IRs, you mostly need to use three external ones. You can't mix the internal and external together. Then the calibration side. So if we were doing the normal one, the normal line following, we need to do the calibration manually. We need to find the threshold value and everything. But here in the case of PID, we don't need to do it manually. We can use this particular block to calibrate the IR sensor. So it will be going to calibrate it by using the checkpoints. So I'll tell you what are the checkpoints mean. In that arena, we were seeing different junctions, like two different lines paths are interconnecting. So those are known as the checkpoints in case of PID sensor. Then here you can see that if you are changing the robot calibration or if you are connecting with the PID blocks, your robot will be moving more accurately with more speed. But if you are minimizing the robots wiggling, it will be more accurate to do the line following technology. You can see it over here in this videos. So in this case, the robot movement is much more faster as well as accurate. It is making these turns, and in this checkpoints, it's also turning perfectly. So by using this checkpoint, we can turn it as well. So there are particular set of code that will be able to control the checkpoints. So let's have a discussion on what are the pro tips you need to keep it in your mind while you're doing the project. So always make sure that you're covering your IR sensors. What is the necessity? So we'll be mostly do it in a open hall with so many lights from outside as well as the tube lights. So there might be the chances of in getting the interference from the external light. So that going to affect your IR movement. So make sure that you are covering your external IRs with proper covering. Then also check your battery voltage always. Always carry a extra batteries with you and also check the battery voltage before starting the game. Because if your battery is very low, the IR sensor value can be changeable. Like it will be going to work improperly, and you won't be getting any proper movements. That could be the case of low voltage. And also optimize your sensor placement. Do your IR test while you are doing the testing in school or something. Do it repeatedly with different criterias and analyze that what are the things we are having. Just 1 second. So sorry. So we were discussing about the tips. So always make sure that while you are creating your robot, test it in prior, like test it in various surface, various scenarios, and let's see what are the differences coming with your robot. Like when you are placing it on a smoother and glossy surface, what are the difference coming up? When your IR is having high light somewhere from the external light, what are the changes your robot is facing? So test your robot in different surface and different scenarios, so you'll be able to understand the issues you are facing, so we can avoid it while during the game. So next, while you are calibrating the sensors, always calibrator once you are using during the testing part, and also once you are calibrating the sensors, check out the speed. For example, if you are adding too much speed and it is taking a little bit of only timing, you feel like, okay, if you increase the speed of your robot, you may be able to complete all the tasks within the time or complete it in fastly. But at that time, what you will face is you'll also have these issues with the inaccurate movements. So it will be always better to use a moderate speed and get a accurate value than using a or increasing the speed to complete the task. So if you're having any doubts or any queries, just put it in the chat window related to the robotic coding part or anything. Any other doubts? I'm checking the chat window. Okay, yeah, good to go. Let me just go to the next section, the mechanism part. So these were the tips you need to do, or these are the blocks you are going to use while you are creating this particular program in this track 2. And definitely you need to use any other part like the pick and place as well. For example, then only you will be able to take the object from one place and put it somewhere else. For example, if you wanted to complete the hydrating challenge, you need to take the object from the coconut tree and put it into the other area. So you will be able to, you need to add the code for that particular one as well. So next, let's have a look at it, how we can take it from and put into one other place, like how this pick and drop method works here. So for that particular one, you can add all these mechanisms. You can see it over here in this images and of the PPT. We have this mechanism to grip the object. You can grab it by using the servo motors, or else if you wanted to use 360-degree servo, that can be also done. We already have this gripper robots in our query key, so you can use the same method to do it over here. So it will be able to take your object. For example, if you wanted to take your traffic cons, so this gripper method will be helpful for you. And the next one is the pick and place object. So we already having this green plastic parts in our Quirky kit. You can utilize the same and connect it to your robot, and it will be able to help you with the pick and place purpose of vaccination and the snake venom. Then also we are having this water testing module. So you need to grab all those four. If you wanted to add that particular one, that can be also done. Or else for that water challenge, someone asked over here in the chat window, do we need to take it in a single time itself? So that is not necessary, but you can see it over here in this particular video. They made a particular design to take all these water drops in a single time itself, like in a single way. They are controlling, or they are grabbing all these four waters. So that also can be added. So it's like some unique mechanism you can add it to your own robot. So these criteria is not mandatory. You can only use the pick and place or gripper. You can also make these kind of unique mechanism, but make sure that you are not using any sharp or edgy object. So let me just play this video once again so you can have a quick view at it. So on this particular robot, what it's doing is it's taking all these four water drops in a single time, like in a single way. So we don't have to come back again and again to collect one by one. So let's discuss more about the mechanism part. So always make sure that your robot's weight is balanced. So if your robot is very lightweight, it's going to affect the pick and place purpose. If the cube is a little bit higher weight in weight, it will be going to affect your pick and place activities. And you can have your robot weight up to the limit of 1 kg. So you can add some weight parts in the middle to control and distribute the weight equally to all the parts. Or else if you wanted to create any other mechanisms, make sure that the size is coming within, make sure that the parts are coming within the size of the robot. Like if your robot size is coming outwards to that 20-20-20, it's going to affect your participation. Then also add smooth and secure gripping. So once you take it, it was very easy. But in between the way traveling to the next or the drop point, if you are not able to properly grip it, it's going to drop it somewhere. So again, going to lose your time. And also control the mechanism speed and precision. So while you are doing the testing mechanisms in your school or earlier prior to the event, do it properly with various scenarios. So what will happen if the particular block drop dead somewhere the way, how they can take it back. So do the activities, do the different trials with the different scenarios. So you will be able to have a more beyond the robot, how it will be going to work in different scenarios as well. So the time limit is very important thing. You need to keep it in your mind. For the elementary students, it is 4 minutes, and for junior and senior, it's going to be 3 minutes. So you can plan your time and you can complete your task prior, like do while doing the testing. You will be able to understand what are the particular thing you are able to finish it in fast, and what are the things, or what are the challenges it's taking too much time. So in somewhere in between, if your robot is taking too much time to complete a particular task, don't waste all the time over here. Just leave it and move on to the next task. So you can maybe the first task was difficult for you, but the second one could have been more easier. So it will be also going to speed up your time, and also it going to influence on your point table. So always keep it in your mind. It is not necessary to struggle with the one challenge itself. If you are taking too much time, if you feel like you are taking too much time, just put it over there and move on to the next challenge. And this score maximization. So I already mentioned it during the challenge case. If you are doing the challenge manually, the point will be different from the autonomous case. So in this autonomous, you can use the line following technology, and you can independently move your robot without any human interference. But in the case of manually, you can control it. So for the elementary students, they can either choose manual control or autonomous control. There is no criteria they should use autonomous. But in the case of senior and junior, at least they need to complete one particular task by using the autonomous. So that is mandatory for junior and senior. And focus on the points first, then time. I already mentioned it. If you are taking too much time on a particular one, just put it over there and move on to the next task. And you only have the limited time, so don't rush it. Focus on the things you can do it very easily. For example, you may able to do or place the traffic cons very easily in the beginning itself, so do it, then go to the next task. And avoid the foul. So you can see that if you are deviating the path, you can see it over here in the picture itself. From if you are deviating from the robot path and going to this areas, it going to it going to influence in your points. Your points will be reduced according to the foul. So make sure that you are stay within your path and watch your deviations and position. While if you committed any fouls in between the section, you need to place your robot one previous checkpoint. You can see it over here in this image. If you had the foul here, what you need to do is place your robot the checkpoint previously. So that is the rule. And also you can't touch your robot once you placed it in the arena. Once the game is started, the students doesn't have the permission to touch your robot without the judges approval. Any doubts on these cases? Don't stuck with one task, and understand the time. Practice it in prior, so you'll be able to understand what are the tasks your robot can do it easily and what are the difficult ones you're facing. So make sure that you're having good practice before the competition. So this thing is also you need to keep it in your mind, like plan everything in prior. Once you build your robot, you can add all these mechanism. You can try with various mechanisms as well in the while doing the coding and creating the robot. Try different mechanisms. Maybe the pick and place will be feel easy for you, or else maybe the gripper thing was the one easy. Do it and check it, test it. Once you are doing the testing part and the practice, you will be able to understand what are the difficulties you are facing with the robot. Then work on that difficulties and improve your robot. Then only you will be able to win. Any other doubts on this? Any doubts in the mechanism part? Okay, while you are planning to do the task, create your own flow. There is no criteria like you need to do the first one first, second one second. You can do it in your own way. But make sure that the timeline is also considered while you are planning it, because we have this time 4 minutes and 3 minutes. So always you need to finish your challenges within this timeline. Okay. If you are not doubt, we can good to go. So it will be better to use the PID technology for the autonomous code. It will be there available in the extension option. Just go to the picture blocks and the add advanced line following technology. So the PID codes and everything line following technology will be available over there, as well as for further research. It is there also provided in the LMS. You can just search it by using the advanced line following in picture blocks. So this PID going to help the line following technology more accurate and effective compared to the normal case. And you can also use multiple sensors. If you wanted to use two external ones, you can use it, or else you can use the internal sensors as well. Or if you wanted to make it more accurate, you can also add three IR sensors externally. And also while connecting it, make sure that you are placing your line IR sensors properly to get this more advanced smooth navigation. So this PID sensors or the IR sensors is going to follow the black and white line. So while you are positioning it, it will be better to place at least one in the center. So the black lines will be accurately monitored. And also make sure that you are covering your IR sensors so we can avoid the interference from the black lines. So these were the PID values I was mentioning. So we don't need to change the KP and KID's values. If you wanted to control the speed, you can vary this base speed and minimum and maximum. Let me just show the code in picture blocks. Once it's done, we can wrap up the section. So this was the code we were going to use. Like we will be going to initialize the IR sensors. Then we'll be going to I'm showing this example of using external IR sensors. So we need to assign the pins. Then we need to set the PID values. We need to add the particular PID values. Let me just share my screen. So this is the code in picture blocks. I hope it is visible for you. Here I set at the two IR sensors. Then I assigning the values. I left to A1 and right to A1. Here we are having this threshold option. You can either add it over here, or else you can do it by the manual calibration. So the manual calibration is also available. Calibrate IR sensor. You can either use this. Then here we are adding this PID values. These are placed it as a constant, and you can, for adjusting the values, you can change this base parameter. For example, the base is 40. If you wanted to adjust the minimum to 20 or something, you can do it, and you can add the maximum value up to 100. Then once you run this code, you will be able to calibrate your robot, and then you can do the line following. So this was the checkpoint I was mentioning. The checkpoints are representing the junctions in the track. So you can mark it as checkpoint 1, checkpoint 2, checkpoint 3. So what will happen when you came into checkpoint 1, then the next set of code will be going to write down below. So just like this, you can mark different checkpoints. So it's going to be counted by the IR sensors. The first interjunction will be going to mark as first checkpoint, and the next one. For example, first you enter to that track arena, then there is a checkpoint, then you need to make a turn right. So you can add the turn right block here and wait for the next checkpoint. So just like this, you can also utilize this, do line following with PID until the checkpoint deleted. You can also change this value to 1 and 2. So this is the code. This is the basic code for advanced line following technology. For further details, you can also visit the LMS. Any other doubts? Okay, in this case, you can utilize the block I showed you earlier, like this one, calibrate IR sensors. So you can avoid this set of codes and place it down below here. And you can place it on the arena and it will be going to calibrate it independently. So we don't have to manually find the threshold values. That's what I was mentioning earlier. We don't need to manually calibrate it here. You can also use the calibration IR sensors. Place your IR robot in the arena track 2 or the line following arena provided along with the kit, and make sure that there is some checkpoints coming or the interjunctions coming. Just place the IR little bit behind that checkpoint and run this particular code first. So it is going to, your IR going to be checked prior. Like also you can place the arena, utilize the track to arena and place your robot in the home point one to calibrate this particular one. So this one is a basic code we are provided. We need to add more codes here. For example, if you wanted to control the pick and place activity, you need to use the servos and you need to control the movements of servo. So those external codes will be there in your whole code. I'm just giving you an example regarding the basic advanced line following technology. Because for us, we already worked with the pick and place and gripper robot. So it will be easy for us. So I wanted to discuss something else like how we can do the coding in advanced line following technology. Okay. There is no code for Ruby. We done it. Once you added the query key, this will be placed here. Can do the coding and also make sure that you are adding the extension advanced line following and connect your robot with Bluetooth, because you need to use the Bluetooth connectivity if you are going to control your robot manually. Okay, just work on few ideas in the hardware. For example, if you're having any particular idea how to make a movement or create a unique mechanism, you can work on it. For example, if you are controlling it by using the servo motors, you can add the code into here. You will be needing the robot to do the participation, and while you are doing the testing part, you can work on various code. For example, in the beginning level, if you wanted to add the gripper first, you can add it. Or else if you wanted to integrate other unique mechanism code, you can integrate into the code. The coding is completely up to the person who is coding. I'm just giving random examples here for your reference. Yes, we're gonna have to definitely use the query key, and you also need to use the PictoBlock software to code it. It is very mandatory in the case of Tracto. Any other doubts on this? So each team must need to have some have the individual robot, and you need to have your own backup batteries and everything. So during the game and while participating the game, mentors or guardians can only provide the guidance, don't control the robot, and also you need to follow the discipline rules and everything. If you are violating any kind of discipline, you'll be able to face the disqualifications as well. So for this particular coding inside, you need to mandatorily use the PictoBlocks. But in case of PictoBlocks, if you wanted to use the block coding, you can use it. There is no regulations. Or if you wanted to use the Python coding, that is also applicable. Also have a good sportsman spirit during the game and make sure that your robot is within the specified measurement like 20 centimeter, and the team must need to validate the robot and the PictoBlocks code with the verification team prior to your game, and the robot needs to may ask to partially disassemble for the inspections. And the participation time will be also provided 5 minutes for practice. Ensure that the robot and the device is fully charged. If you want any kind of backup, place it, keep it with you and change it before the game. In between the game, if you need any kind of assistance with the battery changing or something, it's going to affect your game points. And the teams receive the game cards from the judge or the volunteers. So what are the things you need to do and don't do during the game? So in that competition area, only the team members are allowed. Pick up your robot immediately when the time ends. Like don't keep it somewhere else. Keep it with you and return the used game cards to the judges or the volunteers. Team need to choose their own strategies to challenge the order. And for the autonomous items, or if you wanted to change the mode, you need to inform the judge in prior or the volunteers in prior. Do not try to damage the field or arenas with any kind of equipments. Like in the case of the robot as well as within yourself, don't make anything or don't do anything that would be going to affect the arena. And also don't try to interfere or touch the other team's board as well. So these are the do's and don't do's. You need to keep it in your mind. And once again, I'm telling you that you need to plan everything in prior and build your robot. Maybe it will be taking a little bit time to build your robots. You need to work on various mechanisms. If you think like this particular mechanism, this type of unique mechanism would be able to help you to complete the challenge more fastly, you can try it and test your mechanism whether it's working perfectly or not. If it's not working, try it again, build it again, improve your robot, and if you feel like something is missing, you can add it. So plan, do, build everything in prior to the game. Have a good practice with the track too, so it will be going to help you to complete the task easily and move faster. Any doubts over here? We are wrapping up the section for now. If you are having any doubts, just post it in the chat window. We'll have a discussion on it. Any doubts? So, if your battery runs out during the competition, you may need to replace it. But with your referee's permission, may you can do it, but it's going to affect your points. So the team strength can be 1 to 3 students per team and one mentor or guide for each team. If you wanted to participate alone, that is also possible. 1 to 3 students per team. And the timing is also very much important. For elementary, it is 4 minutes, and for the senior and junior, it is 3 minutes. Any other doubts? Yes, always make sure that you are changing the battery with a full power battery prior to the game so we can avoid these kind of issues. Okay, so that entire part is fixed in that pond area. There will be a lever you can adjust. Just need to tackle that particular lever to release the fishes into the pond. So if you pull up that particular lever, it's going to drop the fishes into the pond. Make sure that you are releasing two fishes. If it's not released fully, you are going to it's going to affect your points and it will be reduced by half. So for the reference of pick and place robot, you will be able to get it from the LMS. You can just sign into your LMS and it will be available over there. No, you don't need to register every day. Once if you are done, you don't have to register every day. Any other doubts? If nothing is there, we can wrap up our section. Thank you, everyone. Thank you for your joining the meeting. And today we were discussing about the track 2, and for tomorrow we will be going to discuss about the track 3. So it's a new arena for us. So we'll have a deep look into it. We already had few sections and we'll check what are the rules and regulations, what you need to do while you're creating the robot. And just like the track 2, what are the set of fouls and challenges you are going to face. We'll discuss all these basic things regarding the track 3 tomorrow. So make sure that everyone is also joining in the meeting. If no other doubts, we'll be winding up the section 4 now. Thank you, everyone. Thank you for your time. See you tomorrow. Thank you. Good day. Bye.